Welcome to Structure Pedia, and this is the second lecture of the series, Principle of Computer Analysis for Structures. As we discussed in the previous lecture, that is based on the how the process works, how the analysis process should work, what are the things that we need to ask yourself when you do the analysis. Now, that was the process that we discussed, but the key important is that thing is that you need to decide what form you should use for your analysis, because when you do the analysis there is the one more question which is very important, because that will actually tell you how much detail your model is, how much detail you want from your analysis, right? So the process is to decide the form of analysis model. So you need to decide first. Okay. Now, coming, whenever you create a model, you try to break the elements into smaller elements, small elements that, because that can have a different angles, that can have a different forms, or that can have different section properties. You need to combine them, you need to fix them all together, and that will actually form your entire model. So your entire structure is made up of actually discrete elements. So you break them down into different elements. That's what you do. Now, the types of analysis model. Okay, so there are basically three types that you need to consider. Okay, so one is the plane frame model. The other one is the 3D frame model. The fourth one is you do the solid modeling. You do plane elements, beta elements. You use such elements to create the FE models. That is more like connections, or you want your structure to understand the stress behavior. Okay, those things. So coming from the plane frame 2D models. Okay. Now this model actually use only beam elements, basic beam elements, or it can be axial members, that is truss members. So you form your entire geometry. You can have a frame, you can have a truss, you can have a beam. Okay, and then you join all together to form your 2D elements, 2D frame. Now your question would be where I should use these 2D elements. One way is that it could be your frame is 2D itself, so you don't have a choice, you need to form that element. Other way is that you have a repetitive nature. What I mean is that, so you have one frame. Sorry about that. Just need to use different one. So basically, when you have a different frames, right? You have more frame like this. Those are in sequence. Okay. Those have equal spacing. What you will do, you will analyze only one frame, and you can design that one frame taking all the actions, and then you can just based on the design elements that you have in that frame, you just assign those properties to the other elements as well. So you don't have to model the entire 3D structure, you can just model just 2D frame. So this is one of the approach that you can do. What is the benefit of that? Benefit is you don't have to make your model bulky, you don't have to use many elements, you don't have to have your file size, and it's easy to handle. You just need to focus only on three elements, and you know that whatever whatever the whatever the properties you will arrive after designing them, that is applicable to all other elements as well. Okay, so this is quite handy, this is quite easy, this is quite simple. So the simple means you should know what's the purpose, and if your model is fulfilling that, then you should be happy with it. So simplification is something I would recommend. So when you do the simplification, so simplify, important word. It's important actually. It's very important. If you simplify something, and and it actually solve your purpose, you are the best engineer. Nothing can be, nothing can replace that thing. So rather than making things complex, just try to make it easier and simple, which is easy to understand, which is easy to analyze. Now coming to the second one is 3D frame. 3D frame is the another is the same thing, but you have now elements in other direction as well. So you have this is my 2D plane, suppose, and you have this support system. Okay. So this is my y direction. Suppose this is x. Now you have the all other elements in z direction as well. Okay. Then you form that 3D system, or the why you will do that. So if you have a repetitive geometry, then this form is the best. But if you have a different spacing, a different angle, or suppose you have a circular stadium, then also you can use this. Or also the most important thing is you need to check the stability of your entire structure. Okay, you have a different bracing arrangements, and you need to see how your structure is behaving as a 3D. Sometimes people find it easy to just form a 3D element, and they say that okay, it's easy for me to just build a 3D one, so they do it. uh, I would say that if you can do 2D first, you should do first, because it's easy to interpret the results that you get from the model, and you don't have to worry too much. You get a less chance of mistakes. So there's less chance of mistakes, less chance of mistakes. Okay, this is good, but this is good for bracing, stability. So and if you have a irregular form of geometry, irregular form. Sounds great. Now, other thing is now the last one is the FE model using 2D plate or 3D elements. So sometimes you have seen that there's a shell element you use for slab. There is a connection, a special connection, and you form actually a 3D element. 3D. I have used that in one of my research paper that you can find it. I can drop that link on the YouTube this video, where I've created a connection in Abacus, and that actually uses 3D solid elements. Now, why I have to do that? Because I need to understand the stresses at each point, because each stress, each local connection is important. So for the local analysis, connections, okay, and specialized analysis, okay, something you need to do in detail, diaphragm, different. Now, when you're selecting the type of element, you have a different. I've just compared two things in front of you, okay, so that you can understand when you select what are the things that you need to consider. Okay. One way is that you have taken a single line beam model. You take off any software, you create a beam element standing, um, and you assign the properties of that. Uh, let's say we have a shear wall, and you assign the property of that element. Okay, so 500 by 10 mm shear wall, or simple any plate elements. Yeah, I assign this property to this element, and then as I apply the force of 10 kilonewton at the top, I got the bending moment diagram, and based on this bending moment diagram, I get my value 15 kilonewton meter. I will design my element for these forces, and then I can just check it whether it's okay or not. This is the simplified version, right? Purpose. If I don't have to do more things apart from. The other way is that you can say Okay, I want to do some local analysis as well. I don't want to go the simplified version or single beam. I want to create a plate element. So I create a plate of 10 mil thickness, just like this. You mesh it. This is the meshing. Mesh it to break the entire plate into number element. The width would be 500. You can actually see that plate. You can see the entire section because that is formed with that plate. Now you apply that force onto it, and then you compute your you have the stresses. You see your once you analyze, and your software will give you stresses. So what you get, you won't get the bending moment from the software, you will get these stresses. So you got the stresses, you got the stress contours. Once you get the stress contours, and you get the value like 120. Now this equation, I'm sure you guys must be knowing it. If you don't know it, please just drop in the comment, and I will just add in the comment as well. Like what actually is the stress is the stress is equal to bending moment times the distance of that particular point from the neutral axis divided by second moment of area. I is your second moment of area. So here the y it would be, so this is my y because we are checking the at the extreme point. I second moment of area, which would be, because we have the rectangular section, BD cubed by 12. Here the D would be 500 and B would be 10. And D by 2 we are checking at the extreme point. We know the stress is 120. Based on that we got the bending moment diagram, which is 50 kilonewton meter. Exactly same as what we're getting here. But the days are different. There are different advantages of both the cases. One, it is simplified. You get to know the bending moments, what is something you really need, you get it. If you really want to know the stress profile in that plate, and you might be needing that for your connections, you might be needing for something else, you need to know his stresses. So it's good to know stresses. Um, so it's basically good to model as a plate element if you are looking for stresses or 3D elements. So it depends on the how you want to model. So if you have any complex structures and you want to know which method would be suitable, please drop comment in this video, or comment, or you can just drop an email to me, and I can just help you with it, which method you should choose, which is would be sufficient. Also, if you're working, then it might be the case that your team wants to do something, and you think that uh, you can simplify it. Please be open and you can share with them. Okay, why we are doing it. Always ask why we are doing display elements, why we are doing 3D, why, what is need of it. So these are the questions that you should have. And so um, as I've shared today, the forms of analysis that you can do, and I will be coming up with the next lecture very soon. Until then, just subscribe my channel and not keep your notification button on so that you can get the notification whenever I upload the video. There is a very nice course running on for the iStruct examinations. If you want to be a part of it, which is a very detailed one, this will we will go from basics to the high level, and I'm sure that will really help you. So keep yourself updated and stay in touch. Thank you.